Okay, welcome back. We're going to do part 2 of our tutorial. Now, I think it's very important to understand that because we're dealing with quadratics in this section, I'm going to be a bit long-winded. I'm sorry, but that's just the way it has to be. So for part 3, when we've got our solutions, it's always about this thing about factorising, so I'll have to deal with that as we go, okay? I want you to be patient with Jason, okay? Because this is a preparation for Maths 1. It's not a HSC thing or a school certificate thing or an APLAN thing. It's about us getting to know what's going on. Now, the first thing we notice is that we want to see when the quadratic's positive, okay? We also know that this has got some values connected to it. Normally, we would see this way, which is not necessarily misleading, but it's an interpretive approach. And we would say, therefore, what makes that statement true? And we would say x is equal to -1 and x is equal to +2. But in the terms of the positive, we have to think about this with regards to the geometric interpretation and the number line. So what we've got is -1 and 2. Now, it's an upside down smiley. It's a smiley face, so it's not upside down. So what we can do is just think about this is positive. So everything underneath here is not really part of our solution. It's not until we get to here that we identify that both of those values are not included because we're not dealing with this. No, we're dealing with this. Yes. Okay, we're dealing with greater than. So that means after this value, we'll start to get the rising quadratic. Okay, so how do we express this? Well, not like this. That's just helping us get these starting points. Only to start. Okay, because we're not dealing with an equals, we're dealing with an inequality. So we need to do these guys this way. Oh, okay, so they should be annotations. So what we've got is x is less than -1 and x is greater than 2. So they represent the solutions of the inequality. Okay, solution of the inequality. Okay, solution of the inequality. I just want to move that in. Of the inequality. So it's very important that we get that, the inequation. Okay, it's asking for anything that is positive. So that represents our value and it represents the solutions that we're looking for. Okay, less than 1, -1 and greater than 2. Now what happens when our particular value is actually a quadratic? Well, we haven't got that yet, because we've still got these linear factors. It's still being expressed in linear factor form. But linear factor form could be misleading, because you might not be thinking about how to solve this inequation. Okay, how to solve this inequation. So if we come along now and we do the same process we did before, we'll see that it's a smiley face, and we've got solutions at -3 and 2. So that means now this is 0 or negative. So 0 or negative. So that means included in the values at 0, because remember y equals 0, x-axis is y equals 0. Okay, and then everything that goes underneath. So this is going to pitch down and start to pitch up like that. Okay, and then up above is of no interest to us because the inequality is demanding this solution. So this represents an interval. We know that we can express an interval as an intersection using the AND idea. So we would have -2 included with x and 3 included. So this represents the solution. The solution of inequation. I don't need to write that always, but it's the solution of the inequation. Okay, so we're doing it just a little bit differently to what we used to in comparison. All right, now what we're doing here is we're getting a quadratic. We're actually getting the thing that's of interest to us. So these are a curve. Now we don't want to be worried too much about the form of the curve, and we can go through and factorise. So we can do x squared minus 6x equals 0. Taking the x out, we would end up with x minus 6. When is this true? This is true when x is 0 or x is 6. 6 minus 6 is 0. So there are our 2 points. But we're asking for when is it negative? Okay, when is it negative? So if 0 is one of them and 6 is the other one, it's clear that 0 is not part of it. So there's our 0. We'll put a circle. And there's our 6. We'll put a circle. Okay, when is it negative? So clearly we're going to go greater than 0. So it's going to be an interval. So the ones that we're looking for are the interval. Okay, the negatives. That's all we're looking for. Okay, so the solution is 0, x, 6. That's the one we're looking for. That's the solution to this inequation. See the difference? That's a solution to an equation. Now it helps us. It's a helper, but that's all it is. It's a helper. Okay, so don't think you're relying on that. Rely on doing your sketching. All right. So for D, now we can use the same interpretation that we've used previously, which is to try and understand the geometry of a thing like this. So what have we got? We've got, let's do D. It says x squared is greater than or equal to 3x. So literally, in a literal sense, what would we do? We'd interpret this literally. So we have y equals x squared. So there's your nice, lovely curve, y equals x squared. Okay, and then if we scale it properly, what we should end up with is y equals 3x. Steeper. Now, somewhere up here, they're going to cross again. So that cross there. So we've got 2 values, 0 and whatever this one is. So in order to find that, we have to solve this inequation because x squared is greater in this region and x squared will be greater in this region because see the y value is coming up for a given x value, the y value is less. Okay, the y value is going up like that. I haven't drawn that very well, have I? So what are the 2 values? So we'll do that. We'll put minus 3x in. X squared minus 3x. Now that's 0, isn't it? So we can take the x out. So I'm being like a helper. I could write it all as, okay, when is that true for the equals part? X is true at 0 and 3. So this is 3 and that's 0. So there are our 2 solutions. Okay, 0 and 3. But when is it true? Okay, so that's the bit that we have to negotiate. When is it true? When is it equal to? Okay. So when x is greater than, so we colour that in and off we go. In that direction. And we colour that in and off we go. Okay. So the solution is x is less than or equal to 0 or x is greater than or equal to 3. So that's the solution to our inequation. Okay, so I want to put this one on a Wolfram, and it'll probably make me scale it. So that's fine. I'll just do the original one first. So x to the power 2 is greater than or equal to 3x. So what we find is that we get a number like, there it is, look at that. There's the 2 values, 3. So that's a much better diagram than I could have done. So that's a beautiful example of this working well. But they've changed the scaling to make that look so lovely. You'll notice the scaling makes it look so lovely. So that's a beautiful plot. But that clearly indicates the interval under which this blue curve x squared is in fact greater than 3x. So it occurs at 0 and at this number 3. So that's your geometric interpretation. Okay, so that's a very interesting way to look at it, isn't it? All right, so I wish there was a way I could just click that and drag it over and put it in here. Apart from there, I think about how I might do that. Certainly I know of a way, but it's post an insert picture, can we? Okay, so that's our interpretation for that one. All right, very good. All right, so the next one then we'll consider is a mononomial. Now, this is called a non-monic. A monic quadratic has 1 as a coefficient. So this is where it's going to get a little bit long-winded, and I apologise for that. So this will be one video, and then I'll make a question for another video. So we've got 2x squared minus x minus 6 is less than 0. So in this particular case, this is this whole factorising bazaar that we go through. Now I'm going to cheat, but I'm only going to do it for entertainment's value. I'm not going to do it for any other reason, because the next one I've determined I'm going to complete the square and the subsequent one. But today, just for this one, I'll do grouping in pairs. So what I want to do is take this quadratic. This is a factorising method, and I've said I don't teach factorising. So this is really for your entertainment more than it is actual how do I get those, because you've got technology and you can do all of that. But I'm going to make a statement later on about what I want. So for grouping in pairs, what we do is we multiply those and we get minus 12, and then we ask the question, what are the factors? So we've got 12 and 1 plus or minus, so whatever, 6 and 2 plus or minus, and then we've got 3 and 4 plus or minus. Don't know which is which yet. So I want minus x, so if I have plus 3 and minus 4, that should work, and I can put them together. So grouping in pairs says rebuild the middle term, the sum term. So I'm going to rebuild the sum term using 4, so I'm going to have minus 4x and plus x plus 3x. So I better just fix that up. Plus 3x. Plus 3x. So minus 4x plus 3x is tick. So I've got that minus 6 equals 0. And grouping in pairs now says we're going to put that pairing together. Okay? So what's common across there? It's 2 and x. It's x and minus 2. So what's on the outside here? 2x. 2x x squared tick. Minus 4x tick. So that's good. Now if grouping in pairs, if you've selected it correctly, you'll be able to rebuild the other one by repeating this bracket. Very important that you repeat it. What can we put out here that will make 3x minus 6? And it seems to be a plus 3. So that's one pair, 2x plus 3. And the other one is x minus 2. So we've kind of found it using that. Now I encourage you to complete the square to get those. And from that we can read directly. X is equal to 2. 2x is equal to minus 3 because minus 3 plus 3 makes this statement true. So 2x equals minus 3. Divide by 2. So x is equal to minus 3 on 2. So there are our two values. Okay, there are our two values. So when we come to do our 2x squared, we've got our solutions, which we've read up on. We've got plus 2, 1 minus 1, and minus 3 on 2 is minus 1.5, so it's about there. Minus 3 on 2, and it's included, and it's negative. 0 or negative. That's what that symbol says, 0 or negative. So when is this quadratic, 0 or negative? Well, between these two included. So it'll come down and swoop down a bit more, come back up, and we're not interested in the positives. We only want the negatives. So this interval will be minus 3 on 2 included and 2 included. So that is the solution to this particular inequation. Okay, solution to the inequation. So getting these out, quite an interesting challenge. Now that's the last time I'm going to entertain you with factorising, because we're going to do it the long way. Okay, we're going to do it the long way. But before I do that, I want to show you why grouping in pairs or factorising isn't the answer. All right, so let's have a look at f. 3x squared minus 5x minus 2 is greater than 0. So if I take this over here and think about how I'm going to factorise this, grouping in pairs again. So I'm going to multiply the 3 by the 2 and I'm going to get minus 6. And what are the factors of minus 6? We've got 6 and 1 plus or minus. And I don't know what the combination is, but we've also got 3 and 2. 3 and 2 plus or minus. So we might be able to rebuild the sum term using 3 and 2. That seems to work, doesn't it? So if I put 3 there, so minus 3x minus 2x minus 2 is equal to 0. And then what's common across here? 3 and x, and we're left with x minus 1. So if this works, x minus 1. And then what are we going to put out there? 2. Now we have a problem. Houston, we have a problem. If I put a minus there, that'll make minus 2x, tick, but it won't make minus times minus is a plus. That won't work, okay? So this pair that I've chosen is incorrect, okay? So I'm just going to cordon that off. So I've had to stop my work and come back. I'm making a point about time, come back, and I'm going to rebuild it again. So I've got to try again. So I'm going to rebuild the minus 5x, but this time I'm going to use 6 and 1. So I'm going to have 3x squared minus 6x plus x minus 2. Now if that's worked, what's common across here? 3 and x. That leaves me with x minus 2. Now if this is the correct choice, this will work. X minus 2 will work. Okay, so what can go in here? 1 plus 1. 1x, tick, minus 2, tick. So that works. So 3x plus 1 is one of the linear factors, and x minus 2 is the other linear factor. So from this I can say that x is positive 2. That will make that true. And that's 3x has got to be minus 1. So 3x is equal to negative 1. So x is equal to negative 1/3. So negative 1/3. So they're my two solution values as helpers. Okay? Alright, so that's good. So what I can do is put them up on here and put this across here. And my values are 2, 1, 2, and minus 1. So minus 1/3 is about here. Okay, minus 1/3. Alright, so this is an inequality where they're drawn this way and this way. And they have to be 0 or positive. That's what that inequation tells me. So if it's 0 or positive, then it's got to be above. So there you go. Above. Okay. Now, we had to reset and this is why I don't like teaching factorising, because errors are made and students get frustrated. So once you learn a particular method, why spend years and months learning another method to do the same job? So just learn one method and make it work. So we're going to redo that. In terms of completing the square. Okay, so this is where I'm apologising to you. So we've got x is less than or equal to minus a third, comma, x is greater than 2. Greater than or equal to 2. So that's the solution for the inequation that we're representing. Okay, the solution to the inequation. All right, so what I want to do is I want to get to those values again, but this time I want to use completing the square. Now, why completing the square, Jason? Why can't we learn grouping in pairs or guess and check or any of those kinds of things? Because the skills that you'll need in Maths 1 are better spent, the energy is better spent on completing the square than it is in things like PSF, cross multiplication, grouping in pairs, guess and check, whatever you want. Okay, the little obvious ones we can do, we've already done a couple of examples, but other than that, what we really want to do is invest our time in things that will pay off. And completing the square is going to be more help in your future work than any other thing. Okay? All right, so for this particular example, we've got the solutions, and I could stop there, but I'm not going to. So I'm going to take my 3x squared equals 0. I'm going to change it from a non-monic to a monic. And I'm going to keep everything on the left-hand side. So I'm going to take the coefficient of the middle term and I'm going to halve it. And then I'm going to take minus 5 on 6 and just put a circle around that. Then I'm going to take that and square it. So this is all scaffolding because we're just doing an operation. Minus 5 on 6 all squared, which means that we'll get 25 on 36. Now that's a square number that goes together to build the next part. So these are just operations of help. So minus 5 on 3x, and then we're going to add 25 on 36, and that is the form of a perfect square. And that is that one. So let's check it. X times x squared, tick. X times minus 5 on 6 times 2. The 2 will cancel with the 3, so you get tick. And minus 5 squared is 25, 6 squared is 36, plus tick. So we've got all three terms. Now we just can't willy-nilly add one, but we're going to stay on this side and subtract one. So we're going to put minus 25 on 36. The other thing we can't forget to do is to bring the 2/3 down. So minus 2/3, and we're keeping it on the left. We're not plus or minus to both sides, or adding to both sides, or any of those things. We're keeping it all on the left. If we add, we subtract on the left. And the reason for that is the geometric interpretation. All right, so this is a bit awkward because we've got to do 12. 12 3s are 36. So that's going to be minus 25 minus 24 over 36, same family. Okay, so that's minus 49. Minus 49 on 36. So now that's a geometric interpreter. We've got minus 5 on 6 and minus 49. So there it is. There's your shifter and there's your point. So that's the reason for doing the completing the square, so that you can apply the geometry if you need to. Okay, now we're still finding the solutions. So what we'll do is we'll process this. So we're going to add 49 on 36 to both sides. And you say to me, well, hang on a minute, mate, this has taken a lot of time, but I'm doing all the steps, and the fact of the matter is, it's quicker overall. Remember when we stalled on grouping the pairs? So how much time is it? It's relative. This skill is going to give you horsepower. It's your lightsaber in Star Wars. It's your Iron Man suit. It's your, double turbo supercharged V8 drop down, lights on the bottom supercar. Okay, this is the way that you're going to make progress. Okay, whatever it is that really incites you and excites you, this is the horsepower method that I want you to embrace. So we're going to undo on both sides. So we'll get plus or minus the square root of 49 over 36. All of these attended skills bring you horsepower in Math 1. So we're going to add 5/6 to both sides. And yes, dealing with the fractions. Okay, knowing when the fractions are annoying and knowing when they're not. So here we're going to do 49 over 36, so that's gymnastics. Then 5 over 6 plus or minus 7. 7's a 49, 6 is a 36. Oh, look, that's not so bad. 5 plus 7 is 12. 12 over 6. 5 minus 7 is minus 2 over 6. So we've got 12 over 6 is 2, and minus 2/6 is minus 1/3. Okay, guess what? They're the same. Okay, they're the same solutions as you got up here when you had your process of grouping in pairs. Grouping in pairs isn't going to help you in Math 1. Completing the square is. So just complete the square. I'm not going to do the grouping in pairs again. I've done it now twice for your entertainment, and that's all I really value it as, entertainment. I'm going to find these by completing the square. Okay, this skill, these sets of individual skills that you're doing, much, much, much more valuable going into Math 1. All right, so the final one then is G. So we'll do G, and the video length is not too bad. Okay, so we've got 6x squared minus x is greater than 2, so we're going to subtract 2. And so the one that we're looking to do is this one. And so I'm going to complete the square on this because I don't know what it looks like. So 6x squared minus x minus 2 is equal to 0. Divide through by 6. So they'll cancel, so we're left with x squared minus 1/6 x. Now minus 2/6 is minus 1/3. Okay, now the steps are we take the coefficient of the middle term and we halve it. We take that and square it. That's the square number that goes together with those two terms. In this form, check it, tick, times 2, tick. There you go. Now we can't just willy-nilly add 144. We've got to subtract 144. And then we've got minus 1/3 on the left, keeping everything on the left because we're nearly there with the shifter. Now this is annoying because we've got to do a little calculation. Now I know, I understand that, but I want to make sure that you're bulletproof with completing the square. So I'm just going to do 144 divided by 3 and see if that works. 48. So we need to multiply both sides by 48. So that's our 1 in disguise. So we get x minus a 12th squared minus 1 minus 48 over 144. So that's closing the fraction. Minus 49. Now look, we've got squares. These are easy. It's not as big as you think. So putting the square over, just adding fractions, really? You're going to retreat out of your engineering and science course because of adding fractions? I don't think so. I don't think so. You need to conquer these. Okay? Adding fractions. You're not going to do it. X minus 1/12 squared is equal to 49 over 144. Okay? So we're going to undo both sides. X minus a 12th is equal to plus or minus the square root of 49. I'm doing every line here, so some of you will be skipping ahead already, which is fine. I'm going to add a 12th to both sides. Undo. You know, this is the thing that's going to make you solid in Maths 1. Okay? Getting this stuff sorted out. So 49 over 144. Okay? So we've got 1/12 plus or minus 7 7s are 49, 12 12s 100. Oh, that's not so hard now, is it? 1 plus 7 is 8 on 12. 1 minus 7 is minus 6 on 12. 8 on 12 is 3/4. And that's right, isn't it? Oh, 8. 4. That's minus a half. Just fumbling there. So if I do 4 on 4, 2 4s are 4 by 2 4s. 2/3. Sorry, my bad. So that's all right. It's making me do it. It's making me do it. So the 4s will cancel. 4 2s are 8. 4 3s are 12. 2/3. Okay. So we've got 2/3 of minus a half. Now, when they're fractional like that, that means, therefore, x is 2/3 and minus a half. So that means that when we put them back into a linear factor and say they're equal to 0, helper, what we're saying is that x is 2/3, it's minus 2/3, and x is minus a half, so it's plus a half. Now, when is this 0? And when is this 0? Okay, so in order for it to be 0, x needs to be plus 2/3, but we can clear the fractions here. I know it's a little bit of work. Okay, I know it's a little bit of work. You can times that by 3. So you'll get 3x minus 2. This one here is x plus a half is equal to 0. So times by 2. So we'll get 2x plus 1. So those things that we actually wanted were 3x minus 2 and 2x plus 1. Now, that's your factorising. Okay, that's your factorising. Now, it's worth the skill, it's worth the patience, it's worth the drudgery, it's worth the frustration, it's worth getting angry with me as your teacher. Okay, you're going to have to trust me on this. Learn to be bulletproof with completing the square, and harder. This is a harder non-monic trinomial. You'll be able to do it fairly readily. Okay, harder non-monic trinomial. Okay, so what we've got is if we come down here with our solution set, okay, we've got negative a half and 2/3, so it's a little bit more. And what are we saying? It's greater than 0, so we only want the positives. Okay, we only want that one. So that's our up we go, very steep. And they'll come down. This is a bit further away, so it's here somewhere. Not interested in the bottom, really. Okay, but it's there. We're interested in that solution set. Okay, so in this case here, we've got x is less than a half. So x is less than a half. And x is greater than 2/3. That is the solution of this inequation. Okay, so we had the bugbear of the drudgery of the gymnastics, but we got there. If you can do that, you're an M1 student. Okay, if you can do that, you're an M1 student. Now, just to check that, we'll use technology and put that in. So we've got 6x squared, because you know I'm happy to demonstrate to you is greater than 2. That's how it was originally, wasn't it? That's how it comes out in the question. Greater than 2, 6x squared, and there's our two values. Okay, half, 2/3. There they are, 2/3 and a half. They're our solutions. Aren't we good? Okay, so listen, it's just a case of me convincing you that if you're going to do well in Maths 1 and your future engineering career, you must be able to do completing the square. I'm sorry it's a drudgery when it's a non-monic and it's got a lot of fractional bits in the end, okay, that you've got to reconcile. I'm sorry that you've got to do it. But if you want to be an engineer of some note and you want to be a scientist of some note, come on. This is really Year 10 stuff. Kids shouldn't be coming out of school without being able to do this without Year 10. All right, that's enough of me whinging. I'm going to stop the video there and I'll be back to do question 4. Thank you.